So, what have they done, these Nobel Prize laureates? Well, they actually sent away a 3-step rocket. The first step was this one, the second is this one now. We'll come back to them now. You see, the first step was taken when Ari Warshel visited Martin Karplus at Harvard in the beginning of the 70s. And together, they devised a method where they described planar molecules, because the thing they did could only be used for planar molecules. To calculate the infrared and the UV spectra of these planar molecules. And the thing which is indicated above here and below that is what chemists call pi electrons. These are electrons which are above and below the plane of the symmetry. And the remaining part is the sigma skeleton, as we say, that is the nuclei and the bonds, the electrons which are in the plane. That was modeled classically, but the pi system was modeled using quantum physics. And they actually made good success in this type of modeling. So this was the first time anybody ever merged a quantum and a classical world in chemistry. A few years later, Warshel and Leavitt wanted to lift this restriction that it only could be used for planar systems. And they used it to study lysozyme. This is, you see the big white thing is the full protein, and this is the yellow part here is the thing which they studied, which is a small part of it, and it has a catalytic effect. And what they did was that they studied the catalytic effect of this protein. And this part here, which is this part here, that was studied quantum chemically, and the remaining, the yellow part, was studied using classical mechanics. And they got insight into the mechanism of this catalyst, or this enzyme. But they didn't stop there. They did something more. They coarse-grained they showed that you could make a coarse-grained model where you lump together particles. As you see here, what we have here is a protein chain or polypeptide chain. And atoms here were lumped together as indicated by these rings here. So all atoms that were in one ring were modeled as one new particle. And you got a model which looks like this. That was a coarse-grained model. The advantage of this is that you reduce the number of particles. And when you reduce the number of particles, simulations modeling is quicker. So it's all about making the calculations with the minimum needed effort, but getting the maximum possible accuracy.